Good morning, everyone. Today we have that issue with malfunctioning, and it's P0032 trouble code. And what it actually means, it means that the resistance of the heater circuit is higher than normal. It means it's out of range, and probably it's higher than 10 amps, and that it triggers trouble code appears on your dash, and you see that MIL light. And yeah, we're going to break it down and see why it came on and diagnose it. Actually, this oxygen sensor number 1 detects the amount of air, amount of oxygen in exhaust gas, and it compares that to the outside air, and then vehicle's computer adjusted the air fuel ratio according to that amount of oxygen. Yeah, let's see what we have and why we see that light. Alright, we'll break it down and go step by step. In general, depends from the manufacturer and model. Can be some varieties, but location of that sensor is the same. It located just before the catalytic converter. It's sensor number 1, and let's see, I will try to show you. Here we go. There is a downstream pipe and down below the catalytic converter, and this is a sensor number 1, which is known as a oxygen sensor, O2 sensor number 1. Most likely you probably won't notice any issues with your engine performance, but depends on the model again. It can affect vehicle drivability, but in general it just will turn that malfunctioning light on. Also, one important note that error code P0032, which we have right now, is similar to P0031 and P0037 and P0052 in nature, and they usually can be related. You might as well check those ones too if you have. A little bit more information I would like to share with you, and O2 sensor needs to reach a minimum 750 degrees Fahrenheit to produce an accurate voltage signal, and the ECM control the O2 sensor heater element based on signals from the engine coolant temperature sensor as well, and engine load. Then the ECM control the heater circuit by allowing current flow to the ground. And yeah, we're going to diagnose every symptom what might cause that issue, and go by step, and we're not going to remove the sensor right now, and yeah, see what we find. As example of this, we have vehicle, the Dodge Caravan with a 3.3 V6 engine, and to get better access to the connectors and sensor, we need to remove the air cleaner housing and air induct pipe. Now we have our air cleaner housing removed. There is only one 10mm bolt over here, and also you remove the connector from the mass airflow sensor over here, and lose the hose clamp, and it will come out. Now we have way better access to the O2 sensor connector. This type of sensor has 4 wires. One is responsible for sensor ground, another is a signal wire, and 2 of the rest wires is heater wires, which is supposed to be the most reliable design. Alright, undo the sensor connector. It's pretty clean. We don't see any moisture here and dirt, which is a good sign. And we're going through all causes and checked what power. Before we're going to test the circuit and sensor, I would like to talk a little bit about the causes, what might cause that issue. One of them is most important, is short in the heater circuit in the sensor. Also, sensor can be faulty itself. Might be your wiring connector or wiring broken, fried after that excessive heat on the sensor side. It normally can happen. Also can be relay issue or no power supply to the sensor, or another thing can be your PCM computer unit faulty. Also, I can say if circuit electrical resistance deviates plus minus 10%, which can be cause of triggering the code, and when PCM doesn't detect any voltage change from the period of 10 seconds, 8-10 seconds from the sensor, it can throw the code as well. And yeah, this is now interesting part begins, diagnostics. If you're not getting voltage at the connector side, it might be blown fuse due to the short to the ground or power, or yeah, can be open circuit. And checking this, we have our voltmeter at the voltage settings, and we're looking for the power. You see the power is coming to the sensor, which is show that computer is working. We have a power, and there's no short or blown fuse, and relay works.
It's time
we
to
have
remove the
turn to the
oxygen sensor
on position, and when you accelerate it,
the
voltage
oxygen
should
sensor socket. It's a 22 mil or 7/8 swivel and a breaking bar that gives us plenty of room to reach the sensor, and yeah, we should do it pretty easy.
Alright, we got the sensor loose with the breaking bar. Now it's all free. We can remove the socket and do it by hand. It spins like this. Sometimes it can be a nightmare. You might need to spray penetrating oil, let it soak overnight, but in our situation we're liking this as a guide. It might be time to replace it, and might be good. But biggest mistake when people see that code, they think, oh, my sensor is bad, and they're going to replace the sensor right away. But sensor might not be the issue, and maybe something very simple like broken wire or loose connection. Let's see. Before, we're looking for fried, burned, broken wires at the sensor sides. Is where they actually can be the problem over here, but at our situation it all looks factory made solid good. At the plug-in side, or clean and good shape. I can say it might be the sensor, but we don't know yet for sure. We need to verify. As we tested before for the power at the terminal, we're checking ground circuit for continuity. Let's see what we have. We have a good ground at the connector. Ground is not an issue, and we have a power supply. This side is no issues, and that might be a sensor, probably, but let's make the experiment. Okay, oxygen sensor, they're known as a voltage producing sensor. You want to read the voltage change, depends on the amount of oxygen change due to the heating up. We have propane torch there, and we're checking the voltage between those two wires, which is a ground and signal wire. Go like this, and we should see about a 1 volt. Yeah, we have 0.8, and as soon as we pull the torch, it should drop down to almost 0. With 0, we're going to heat it up. We have 1 volt. It shows that oxygen sensor is picking the readings of the amount of oxygen in exhaust gases. Put out almost 0. It means less oxygen we have, or burning right now oxygen, higher voltage goes. As soon as we remove the heat, we have more oxygen. The sensor is functioning at this point, but as we had a code heater circuit high resistance, we need to measure the resistance between those two terminals for the heater circuit. It should be between 5-10 ohms. Okay, we don't need this. Next, we're going to measure the resistance for the heater circuit. We set our multimeter to ohms. It's ready to measure. It shows OL. Now we check it, make sure it's all working. We have 0.3 ohms resistance like this, and there is no resistance at all. It's open circuit, and we want to see between 5 and 10 ohms resistance on the heater circuit. I remove the top part from the connector for better access, and we're reading from those two wires. There's nothing showing there. It means that circuit is open and that heater element wore out, and there's no electricity flowing through. Let's check the new one. Like so. It shows us 8.7 ohms, which is normal. It's in a working condition. Here we go. We found what's wrong. We traced the issue down, and that was a heater element problem. And this is how you diagnose and troubleshoot that P0032 code on your vehicle. Oxygen sensors, could be 4 different types. Like this one, for example, has 4 wires. 2 black wires is heater element wires, and ground wire and signal wire. But if your sensor has 1 wire, it means it's only signal wire and sensor grounded to the chassis through body. 2 wires mean it's more reliable. It has own ground and signal wire, or if you have 3 wires, it means only 1 wire is the heater wire circuit, which is better than nothing. Alright, and yeah, as soon as you going to replace your oxygen sensor, check for continuity, for ground, blown fuses, relays, connectors, might be some debris, might be broken wires, open circuit, and yeah, just find what caused that issue and then solve it. Alright, thank you for watching this video, and we're going to put everything back together
installation is the reverse of opposite of removal. Okay, stay tuned. Thank you. We got all parts put back, and now it's ready for start. And what you're supposed to do next is just erase the code, and that should be it, and see if it will come back.
We have this code. We're going to erase. Push this button. Okay, yes. Erase was successful. That should be it. And turn it off. We're going to start the vehicle and see if that engine now will come on again. Before, when I first time had that code, I erased it, and as soon as I started the vehicle, engine light came on just immediately. Let's see what's happening. Well, at this time everything seems to be okay. We'll keep monitoring the system performance, and it shouldn't be the problem. It's funny how those lights are flashing, your eye cannot pick it up, but camera can. Alright, thank you for watching.